Hi friends, welcome to our lesson. I'm Mrs. Gridney, and today in our lesson, we'll be comparing fractions greater than 1. We've learned lots of methods for comparing fractions up to this point, and today we'll have the opportunity to practice using them all. So let's get started. Take a look at these two mixed numbers. What do you notice? You probably noticed that they have the same whole number. They both have 3 ones. That means we can compare the mixed numbers by comparing the fractional parts, 3/8 and 3/4. So how might we compare 3/8 and 3/4? Pause the video to talk out your thinking. You may have noticed that the numerators are the same. That means we can compare the fractions by thinking about the size of the units. Eighths are smaller than fourths, so 3/8 is less than 3/4. Or maybe you thought about benchmark fractions and you pictured a number line in your head. 3/8 is less than 1/2, and 3/4 is greater than 1/2. Again, that tells us that 3/8 is less than 3/4. So 3 3/8 is less than 3 3/4. Let's read this comparison statement aloud from left to right, just like we would read a book. 3 3/8 is less than 3 3/4. Great. Now, can you think of another way that we might compare the fractions? Maybe you noticed that the denominator 4 3/4 is a factor of the denominator 8 3/8. That means we could make common denominators by renaming or converting 3/4 to a number of eighths. Let's use tape diagrams to model this. Pause the video and draw a diagram to model 3/8 and another one to model 3/4. Draw the diagrams one on top of the other and line them up and make them the same size so that we can compare, just like you've done in other comparing lessons. When you're done, come back and we'll continue. Welcome back. Be sure to compare your diagrams to mine and make sure that they match. Now, what do you notice about our diagrams? Maybe you noticed that the units are not the same size. So what could we do to make them the same size? We could partition each of our fourths into 2 equal parts to make eighths. Let's do that now. Now, how many eighths can we see are equal to 3/4? 6/8 equal 3/4. Now that our units are the same size, we can just think about the number of selected units. So which fraction is greater? 6 is greater than 3, just like 6 apples is greater than 3 apples. So 6/8 is greater than 3/8. That tells us that 3/8 is less than 3/4. So again, 3 3/8 is less than 3 3/4. We verified our comparison using another method. Way to go. Let's try another one. Let's compare 4 3/4 and 23/5. What strategy might we use to compare these two numbers? Pause the video and talk out your thinking. You may have noticed that 4 3/4 is written as a mixed number and 23/5 is written as a fraction greater than 1. And you might be thinking that they'd probably be easier to compare if they were both written as mixed numbers. So let's convert 23/5 to a mixed number. Do you remember how to do that? Remember, think about how many fifths equal 1, 5/5. Then think about how many times you can pull out 5/5, and then how many fifths are left. Pause the video here and rename 23/5 as a mixed number, and then come back and check with mine. Welcome back. So what is 23/5 renamed as a mixed number? It's 4 3/5. This is one way that you may have thought about it. This is how I thought about it, but it's not the only correct way. Here's what I did. I skip counted by 5/5, since 5/5 equals 1, like this. 5/5, 10/5, 15/5, 20/5. 20/5 is equal to 4 ones, and then I still had 3/5 left, so 4 3/5. Now that we have two mixed numbers, 4 3/4 and 4 3/5, what do you notice about them? You probably noticed that once again, the whole numbers are the same. These both have 4 ones. So that means again, we can compare these mixed numbers based on the fractional parts, 3/4 and 3/5. So how might we compare 3/4 and 3/5? Pause the video to talk out your thinking. You may have noticed that 3/4 and 3/5 have the same number of selected units. The numerators are the same. So that means we can compare them by thinking about the size of the units. Fourths are bigger than fifths, so 3/4 is greater than 3/5. That tells us that 4 3/4 is greater than 4 3/5. Now, what does that tell us about our original comparison? Right, 4 3/4 is greater than 23/5. Way to go. Let's confirm our comparison using another strategy. We have fourths and we have fifths. Since these denominators are unrelated, what model can we use to create common denominators? We can use an area model. So pause the video here and draw two same-size area models, each representing one whole. Partition one into fourths using vertical lines to show 3/4, and partition the other one into fifths using horizontal lines and show 3/5. If you remember how to create like units in the area models, then go ahead and do it. If you don't remember how, that's okay. We'll do it together when you get back. Welcome back. Do your area models look like mine? Notice I partitioned to make my fourths using vertical lines and partition to make my fifths using horizontal lines. Now let's create like units if you haven't done so already. How will we partition our fourths? We'll partition our fourths into 5 equal parts using the same lines that we have in our area model showing 3/5. So let's do that now. Okay, now how will we partition our fifths? We'll partition our fifths into 4 equal parts using vertical lines, just like we have in this area model showing our fourths. So let's do that now. Great. Now all our units are the same size. So what units did we create? We created 20ths, right? And how many 20ths are shaded in the first area model? 15 20ths are shaded, so 3/4 equals 15 20ths. How many 20ths are shaded in our second area model? 12 20ths are shaded, so 3/5 equals 12 20ths. So how can we rename 4 3/4? We can rename 4 3/4 as 4 15 20ths. And how can we rename 4 3/5? We can rename 4 3/5 as 4 12 20ths. Now we have like units, we're just thinking about the number of selected units. So think about how we would read this comparison from left to right, just like we would read a book. Read the comparison and say the answer. 4 15 20ths is greater than 4 12 20ths. So what does that tell us about our original comparison? Well, 23/5 is equal to 4 3/5, which is equal to 4 12 20ths. Since 4 15 20ths is greater than 4 and 12/20ths, 4 and 3/4 is greater than 23/5. So we've confirmed with another method that 4 and 3/4 is greater than 23/5. Great job. For our last example, let's compare these two numbers, 3 and 7/10 and 18/5. What do you notice about these two numbers? You probably noticed that they're written in different forms. 3 and 7/10 is written as a mixed number, and 18/5 is written as a fraction greater than 1. So what should we do? Let's rename the fraction greater than 1 as a mixed number. So pause the video and rename 18/5 as a mixed number, and then come back and check your work with mine. Welcome back. Did you find 18/5 converted to a mixed number is 3 and 3/5? If so, way to go. If not, be sure to pause the video and compare your work to mine and see if you can fix your mistake. Now that the two numbers are written as mixed numbers, it makes them friendlier to compare. So pause the video here and compare the two numbers using whatever strategy you'd like. Be sure to write the comparison symbol in our original comparison. When you're done, come back and we'll discuss. Welcome back. How'd you do? Hopefully you noticed when you were comparing that the two mixed numbers have the same whole number. They both have 3 ones. So we could compare them based on the fractional parts, 7/10 and 3/5. Here are two different ways that you may have created common denominators so that you could compare the fractions. Does one of them look similar to how you thought about it? Now, why wouldn't an area model be the best choice for this comparison? You may have noticed that the denominator 5 and 3/5 is a factor of the denominator 10 and 7/10. That means that to create common denominators, we only needed to rename 3/5 as tenths. We didn't have to do anything to 7/10. Area models are really more helpful when we have to rename both of the fractions that we're comparing. So let's read our original comparison from left to right. 3 and 7/10 is greater than 18/5. Excellent work today, friends. You all did so well today. I think you're ready for the problem set. On the screen are the must-do problems.